everyone. So when I like to talk about, I like to talk about the big things that organisations around the world get worried about, because basically I like breaking big stuff, right? So I'm Barry Myles. I work for BT and I run an internal pen test team at BT. And one of the things that we do is we do red teaming, and we do it within our own organisation, but we also do it commercially as a service to other companies around the world. And pretty much every red team assessment that we've ever done has involved Active Directory security in some way. And so when back a few months ago, when OWASP Suffolk started up, I thought I was sort of thinking what people would like to hear about, and sort of important topics that are relevant to the security industry. Now, OWASP, of course, is the Open Web Application Security Project, and actually, Active Directory doesn't have very much to do with web. It's almost everything that isn't web in security in organisations. So what I'm going to do is we're going to talk a bit about, well, we better start off with what an Active Directory is. How many people know what an Active Directory is here in the organisation? There will be some. Yes, good. Anybody doesn't, that's really okay. These things are, nobody's brave enough to stick their hand up. But yeah. Okay, so we'll do a bit on what an Active Directory is. We'll also do a bit about why this is a really, really good thing to go attack, both from the point of view of doing a security assessment within an organisation, but also why a real attacker would go after it. Now, one of the things is that there's various techniques that can be used on Active Directory, which sort of give you a path from starting off as a very low user up into much more powerful users, and we'll talk a bit about that as well. And what I'd like to also do is talk about sort of consequences. What happens when this goes badly wrong? And largely because it's OWASP. Now, I'm an attacker. I love breaking things, right? But OWASP is, we're supposed to think about how you defend things. And actually, this bit's really tricky for me because most of the time it's like, don't care, it's broken. But we'll talk a little bit about how do we defend. Right, so what's an Active Directory? Well, one of the problems with Active Directories is that actually almost every organisation, probably large organisation in the world, has an Active Directory these days. And one of the problems with Active Directories is it's a product by Microsoft which is included in Windows Server, roughly, and it tries to do too much, right? Now, I've put a big list of things up there that it tries to do. And actually, all these are important for the talk, right? So every organisation needs to know all the people within it. So Active Directories contain a list of usually every person within the organisation. Quite often the people set up pseudo people to represent sort of roles and functions, so like help desks and other things like that. Sorry?
Rooms.
Rooms. Meeting rooms. Meeting rooms often have...
Which is really interesting because you give away everything about your organisation.
Yeah, you do. They're fantastic. They also contain a directory of certainly most Windows computers within an organisation, and quite often these days Macs and Linux machines as well. They're also a digital certificate authority, so certificates, and the certificates tend not to be used on websites with TLS, although they can be, but they're often used for other purposes, particularly for identifying the trust in machines. Another important thing is they have groups of people. So you've got people in an organisation or people who have access to a particular resource, like everyone who's got permission to book this meeting room, for example. Active Directories, and this is where the sort of security bit comes in, they store the authentication information for an organisation. So in large organisations, when you sign on with a username and password, that information is stored within the Active Directory. Now, as you can probably see, you're sort of thinking like an attacker. That's what I want. I want all that authentication information.
And it's really nice because they put it all in one place.
Yeah, well, exactly. And this is also where this concept of single sign-on, because actually it's really awkward for organisations to maintain lots of usernames and passwords. They want one username and password that works on everything with an organisation. Now, there's obviously upsides and downsides to that. There's if that leaks or gets lost or something, you've got access to a lot of things. But it's incredibly convenient for in an organisation for it to have single sign-on. And it's also got a naming function, so it's rooms of names, people of names, computers of names. Active Directory does all that. The key thing about Active Directory is, in Active Directory, that there's these machines, Windows servers called domain controllers, right? And these things are the central hub of an organisation. They are often the most important computers in the organisation. And of course, important computers means that's where I'm going to go after as an attacker.
Yeah.
Okay, so we're going to talk about different attack scenarios. And actually, the attack scenarios that we're dealing with here are probably a little bit different from what you traditional web type attacks. Because as security professionals, we're very used to dealing with web attacks, with things like somebody trying SQL injection to dump a database, like, and this is where there's a lot of these big info leaks. I'm guessing everybody in this room has probably lost some set of usernames and passwords over the last few years. That's where they come from. But we're not really talking about these kind of things. The attacks that we're really talking about here are things like a lot of companies worry about malicious insiders, so sort of rogue staff members or contractors, because when you get to a large organisation, most employees are probably like the lovely people in this room, well-behaved individuals who really want to promote the goals of an organisation. But the fact is that there's a whole bunch of people out there, for whatever reason, want to do damage, or perhaps just after money within an organisation. So malicious employees are something that Active Directories have to resist. You also got this scenario where you can get some machines, and sometimes they're web servers, and they've got two network connections, one facing the internet and one on the inside. Now this famously happened to Sony Computer Entertainment, where they got their Active Directory completely taken over. And it was this middle scenario. That's happening a bit less these days. A lot of organisations tend to put their web servers in cloud platforms like AWS or Google Compute these days. So this scenario is something that doesn't happen quite so often. And largely, and the third one that companies worry, most organisations worry about, is just simply somebody walking into an organisation off the street. And plugging in. So how difficult would it be, for example, if you didn't know anything about the University of Suffolk, to walk in off the street and connect into that network port over there? Say I come along with a little computer, like a Raspberry Pi, have a 4G modem on it so I can talk to it remotely, and walk in off the street and plug it in. Suddenly I've gone from being an outsider on the street to being an insider within the organisation. This is a powerful attack scenario, and as someone who leads a red team, we do this absolutely all the time, and we rarely fail at this particular one. Okay, so one thing about Active Directory is that if you don't have an account on an Active Directory, the way that it's set up is it just won't talk to you, right, at all. Now, for some of these attack scenarios, that's not a problem. So if you're a malicious employee, the chances are you already have an account on one of these to get going, just to get your attack working, right? But in the second and third scenarios, you need an account to get into the to get going to talk on the thing. So one of the things that we think about when we're doing attacks is, how do you get your first Active Directory credential? Where does this come from? I've just walked into the street. Where do I find one? Well, if you're the University of Suffolk, right, you've got an Active Directory called UCS, and the reason why I know so is because it's on the screen in front of me here, right? And we need a username and password to get onto this machine. So that's the terminal there. And where do you get a set of Active Directory credentials? Well, this sticker's really interesting. It contains the username and password. And they're not just the username and password to get onto this PC here. Using these credentials, I can actually get onto pretty much any computer within the building using these credentials. In fact, if I was to go up and try to log into their email on their website with these credentials, and don't try this because that's not allowed, but my guess is they might just work. Yeah. So that's one way of getting Active Directory credentials. People write these things in crazy, stupid places like there. It's like, yeah. And it's amazing how many of these appear with an organisation. Carefully...
I will not tell you also.
Doesn't really matter. Actually, this is quite unusual. There are other ways of getting Active Directory credentials within an organisation. I'm going to mention some of them. There are really rather a lot. My favourite one is this particular attack called Windows Responder. Right? Anybody who's here has heard of Windows Responder? No, interesting. So this is one of the single most powerful attacks against Windows machines, Windows networks that are around. And it's largely unknown outside of a very small hacking community. So, how many people here remember MS-DOS 6.0? 1, 2, right? Around about that time. Okay, so... Ethernet networking, not like this, but the old style. Used to be different cabling, right? But it's still the same thing. It actually predates the internet, right? And it's a broadcast network. So if you've got all the computers connected to an Ethernet network, they all can talk to each other. In fact, once upon a time, that's all there was. And way back in these days, there used to be a Microsoft protocol. This is pre-internet, called NetBEUI, right? Now, NetBEUI was horrible, right? It was designed for a small office, and everything worked by broadcasting. So there's no real type of addressing or anything. And the way that machines found, you imagine a small office this was designed for, and Microsoft it was like a predecessor to their server product, made something that sat in the corner. It was a file server. You could access your files from other MS-DOS machines, which was their key operating system at the time, pre-Windows. And the way that MS-DOS machines found these server machines was using this NetBEUI broadcast protocol. Right? This NetBEUI broadcast protocol and a derivative of it is still there in Windows 10, nearly 30 years later. Right? And this is really, really interesting. So if I'm on the local network here, say I'm plugged into this connection, right? What happens is if you sit and listen with something like Wireshark that listens and sweeps up all the traffic, you will see Windows machines asking if they can see another machine on their network. And there's 3 protocols that this generally happens with. One of them is a protocol called NBNS, the NetBIOS Naming Service. So this is this derivative of NetBEUI. A second one is multicast DNS. Right, which is actually, it says a bit of history, but it tends to be for finding things like modern printers and things. Macs are in particular very, very, very keen on this. And another one, the third one, is this thing called the Link Layer Multicast Name Resolution Protocol, LLMNR, which is a really horrible protocol to say. But all of these protocols are just broadcast protocols, like who's the computer called Fred out here, right? Now, there is no authentication on these messages, right? If you're an attacker connected to there, you can say, hey, I'm called Fred, and you know what happens? The machine on the network will start talking to you, right? Now, Microsoft have got this, this bit, where as soon as it starts talking to you, what are you going to do? It's going to try and make a connection from you. And you're not quite sure what kind of protocol it's done. It tries to do, but it's often network drive mappings or things to a domain controller. You see these two very, very commonly. And what you do as an attacker, you accept the connection, say, yes, that's me. And the next thing you say to the thing is, send me your password hash. Right? And every single Windows protocol that's out there, if you just ask it nicely to send a password hash, it will just do it. So what happens is, and this is a real example of Responder being run within an organisation where we really shouldn't have been there, is it sends there and you can see it's this is LLMNR, so it's going for a name which I've blanked out, but it took a little while. But that big bunch of, that's a really rubbish projector, that big bunch of stuff there is a Windows password hash, right? So if you grab that, right, so if you're in an office with a few hundred people, right, you're sitting on there and you run Windows Responder, you usually get, every 5 or 6 seconds you'll get somebody else's password hashes within a network. And they'll just sit there rolling. You can leave it. It's a little bit disruptive. People notice things a bit slower, and it's prompting me for my username and password on the machines. Don't worry about it. Nobody notices that. And a number of times that Windows in an office network prompts for username and password. People just type it in, and off it goes. And then if you leave it running for a few minutes, close it down. We'll only need one. You'll see in a minute, or maybe a handful. And you get people's password hashes. What do we do with these hashes? Well, there's a couple of things we can do. These hashes are crackable. Now, there's various password crackers out there. A lot of people like John the Ripper. It's not my favourite one. Hashcat is another one. This uses graphics cards within computers. Actually, John the Ripper, a couple of days ago, they've launched a new version of the product which can use field programmable gate arrays now to crack passwords, which is dozens and dozens of times faster and more popular and more powerful. But Hashcat's pretty good if you spend I don't know £2,000 or £3,000 on a big password cracking machine, you can crack for these hashes a few billion a second. You can have a few billion password guesses a second for that. If you start feeding in dictionaries of common passwords for all these password leaks, typically within an organisation, you'll get them in a few seconds. And so you'll find somebody's password within a few seconds. Okay, so we've got one person's credentials. I want more. I want everybody in the organisation's credentials, right? We're going to need to work out how we get there. Okay. So, one of the ways that we quite like to do is that now that we're on a Windows network, we can start, and we have a set of credentials. We can either written off something, or we've lifted them off the network from Windows Responder. We can start actually talking to the domain controller and asking it questions. And because it's an Active Directory, it's a directory. Directories are supposed to contain, they're supposed to answer your questions, just like, I don't know, a telephone directory, a staff directory, or something does. So this is a PowerShell script that is included by default in Windows 10. In previous versions of Windows, you can download it off Microsoft's website. And what it does is it tells you, you can say, tell me what this organization's password policy is, because the computers need to know that, because the passwords are, the actual format of them is validated first locally to make it nice and responsive on a Windows machine. So this thing does it, and this organisation has got some really interesting things. So it forces the users to change their password every 30 days, right? That's really important. We'll come back to that in a minute. The other thing is, this is quite interesting. So you can't reuse the last 140 passwords in this organisation. This is a real one from an unnamed company. There's some other things. There's these various things to do with lockouts. So you allow five password guesses, and if you get them wrong more than 5, you're locked out for 90 minutes, right? So okay, that's kind of useful information. There's more. There's lots and lots of pages to this. Windows has got this ability to restrict password you know, to certain upper or lowercase and symbols and things like that. They're on a different screen. Okay, so we've got a password policy, right? So we're going to need some passwords. So what password are we going to choose? Well, we've got 30 days passwords here. What do you think people are going to set the passwords to? Ooh, that one would be good, wouldn't it? How many people in the organisation do you reckon are going to have the password April 2019? Many? Well, April 2019, exclamation mark, super cool password, or password 1, or April, yeah. So, because it forces you to change it every month, lots of people will just take month plus year name. Yeah, lots of people done it. I hope nobody in the room has done that. Is anybody looking a bit sheepish at the moment? I did a presentation to one company, and we knew exactly who in the room had the passwords, and I stared at them during the presentation, and it looked a bit sheepish. Okay, so this is what we want the password. Now we need some usernames. Well, how do you get a list of usernames? Well, because it's a directory, this Active Directory, you just ask it nicely. On any Windows machine that's a member of a domain, if you type in net users domain, it will tell you the complete list of every user in the domain from the command prompt. You just go and try it. It sometimes takes a few minutes to run on a really big organisation, but you could try on this one, don't. And it will give you a list of all the users. So we've got a password, we've got all the users, and we just try that password on every user. Right? And we can use just about anything. I often use LDAP, the directory protocol, because it talks directly to domain controller that way. But a lot of things are authenticated on the web, or this SMB, which is network drive sharing protocol. Any of these will work. LDAP's a really fast one for doing this. And you just try and log in with the first user in this password, the second user in this password, the third user. Is anybody going to notice? Well, we're not going to lock any user out, because we're only making one guess, right? So we don't lock any user out at all, so nobody really notices. And actually, there's a refinement to this technique we can do, is on an Active Directory, you can actually ask the Active Directory to tell you how many times that user's got their password wrong, any user. And it will tell you. So if you compare that to the password policy, and if it's just one less than the lockout, just don't try that one, go on the next one. So that will get you. And typically, the first time you do it, you'll get 10% of all user accounts on the Active Directory when you do it. And in a big size organisation, I've had it better. So I've had it below 1% in an organisation. Which the first time ago, and I've had it up to 30% in one particular organisation, which you would be shocked at. Not BT, right? Anyway, these people. So this is a password spraying attack, right? And so the first time we tried this within a large organisation, one of my colleagues was looking at the results, and he goes, what are these people like? And he says, they're a bunch of muppets, right? So it's sort of stuck now. It's like every time I call people the victim of password spraying attacks, these people are muppets, right? So this is, and we'll call them muppets from the rest of the presentation, shall we? Yeah. Okay. Right, so there's we've got a large amount of users' passwords. As a benchmark, we've got 10% of all users' passwords. But as an attacker, you don't actually really know where you're going. You know you're at this point. You know there's lots of things in the organisation you'd quite like to go after. There's actually another way of getting passwords, right? But it requires some quite powerful privileges. So if you log into a machine like this one with these credentials, you're not actually administrator on the machine. I hope. I really hope. Okay. Yeah, I'm a bit worried here. But typically you're not. You'd like to become administrator as an attacker. And we'll see in a minute why there's a really good reason for this. So what you'd like to do is basically escalate. your privileges. And there's several ways of doing that on Windows machines, right? So on Windows 10 machines, if they're locked down really well, you can't really do this very well. But pretty much every other kind of Windows machine that's around, apart from maybe Server 2016 and later, you can usually get from a normal user to administrator with a bit of work. And there's several ways of doing that. My favourite one is this particular script called JAWS, which is, and what it does is it's got a whole heap of Windows privilege escalation checking things. So this is just junk things that are around. So there's things like Windows services, they've got their own permissions, or Windows has got lots of caches for things like preloading files so that the executables run quickly. And quite often the privileges on these are just junk, right? And this script goes around, checks them all, and tells you how you can get local administrator. So that, now it's local administrator, right? It's just administrator on this machine and no more, right? But it's still, that's important. That's why it's important. Now, the reason why it's important is because of this next piece of software, right? So this is quite famous, this piece of software. This is called MiniCat, right? What this does is, if you've got a Windows machine, right, you'll notice if you do things like, if you log in with your domain credentials to it, a lot of people, after they've done their domain credentials, what they do is they do something like start Outlook up. And they'll notice that Outlook just works. It doesn't prompt you for any more credentials or anything. And the reason why it works is that Windows has a process running on it, which is called LSAS. It's a local security something service, right? Can't remember. But anyway, what it does is it stores the usernames and passwords and a whole bunch of other credentials of everybody who's logged into that Windows box since it was last rebooted in clear, in memory, right? If you're a local administrator on that, you can read that process's memory out, and you'll get the plain text password of everybody who's logged into that box since it was rebooted. You'll either get that, or you'll maybe get the password hash, which you can crack. Sometimes you get PIN numbers as well, and you get these things called Kerberos tickets, which I won't talk about later, but I could do. So that's one way of getting a set of credentials. The busier the Windows box is, the more credentials you'll get, right? So there's most sort of like standalone machines, people's desktop machines, you don't get very many of. Quite a few Windows servers have got lots of administrators on them. If you get credentials for one of those, you can often get 5 or 6 people's, right? Some organizations have thin client desktops, particularly made by a company called Citrix. And if any organisation uses Citrix, it's the biggest security disaster in Windows networks that can be done, because if you run MiniCats on a Citrix box, quite often you get thousands of people's credentials out of the box. And companies use them as a security gateway to prevent access to anywhere else in the network. And we've seen Citrix boxes in a lot of places, but literally you can get hundreds and hundreds of them with MiniCats off really easy. The other thing that we use for lifting off credentials, which is different, is this thing called Lasagna. So this was written by a guy called Alessandro Zanni, who used to work for BT. What this does is it doesn't go after Windows credentials. What this does is it goes after everything else. So it goes after credentials stored in Firefox and Chrome and PuTTY and instant messaging and all these other stuff that people may have loaded on the machine. It looks on the disk, it looks in memory. Interestingly, it doesn't need a local administrator to run. This will just run as a normal user. As an attacker, when we're looking after Windows machines, the number of people sort of Facebook and Grindr accounts we get with these is just like amazing. But the so I run it. I mean, how many people got Windows machine at home? You should really try running that on personal Windows machine. This is me running on my personal Windows machine at home. It's like Instagram, Airbnb. Oh, some random box which got root and GitHub accounts. Yeah, it finds loads, and that went might have been somewhere down in the basement. I found loads of them there. The other thing is, when you run this in a corporate thing, corporate people often have a lot of internal websites on their intranet, and because they've got all those internal websites, and they're often things like, I don't know, employee payroll or SharePoint and things like that. They are often authenticated against Active Directory as well. So people end up storing Active Directory credentials in things like Chrome. And of course, Lasagna is really good at picking them off. Okay. So, we've got lots of credentials, and we can log into lots of Windows machines with those credentials, right? So, there's several different ways of doing this, right? So this is this concept of lateral movement. So in an organisation, if you've got control of one machine, like this, we'd quite like to and we've got credentials we've got gathered from various places, we'd quite like to go into other machines, right? And this is the sort of thing where we'd quite like to write our own code, or shell code, that lives on this machine and all talks back to a central location under our attacker control. So this is command and control back to our location. To do that, we need to be able to move around between machines. So this is the concept of lateral movement. And there's quite a few ways of doing this. And I've picked out the 5 most common ways of doing this, right? So the number one way of doing it that's really easy to explain is the remote desktop protocol. Right, so most people have done remote desktop protocol, but probably not everybody, right? So what it is a protocol, it runs over a network and it gets you a view of that Windows machine as if you were sitting in front of it yourself, right? So you point at an IP address usually, and it'll ask for a username and password. Oh, we've got those. We put those in and we get the desktop. Right, so that's good. Now, it has a bit of a downside, right, is if somebody else is logged into it at the same time, right, they're going to get slightly suspicious when they see their mouse cursor moving around, right? Now, we actually did this in one engagement that we were doing, where we accidentally, we logged in late at night, like nobody's going to be on it, right? Some sad system admin, but it was in late that night, and he saw the mouse cursor moving around, and the reason he was late was he was going on holiday, and so he thought, oh, that's a bit crazy, he was just about to knock off. So he sent an email to his manager, saying, that we think there's a security problem here, but I'm on holiday, see you in 3 weeks' time, type of thing. And he sent it to manager, and we noticed this. The reason why? Because we had his Active Directory account, we were reading his email, right? And we also had his manager's Active Directory. So what we did is we deleted it out of his sent box, and we deleted it out of his manager's inbox. And then he came back from holiday, and he completely forgot about it. It's ridiculous. So, yeah. So remote desktop is one way of moving around between machines. The second way is this sort of technique that's called PSExec. Now, so remote desktop was a desktop. PSExec is a much more network-based type thing. So Windows machines have got network drive shares on them. If you can find a writable network drive shares, which with credentials you can often do, you can write your code to it. And then you can, there's various things that tell Windows that you have a new service to deploy on the machine. You point it at the code that you've just deployed on the machine. And so your code is now running on the destination machine, right? So that's a technique called PSExec. The problem with PSExec is it touches the disk, right? So if it will trigger antivirus and things like that. So you have to be really careful with it, but it's really powerful. There's this thing called Windows Management Instrumentation. It started off as a way of doing things like monitoring processor speeds and fan speeds and disk utilization and things like that. Microsoft added to it on every single version of Windows that came along. In later versions, they added the ability to run arbitrary PowerShell scripts to Windows Management Instrumentation. So if you've got credentials that allow you to check out the instrumentation of a Windows box, which quite often you do, usually sort of middle level administrators can do this. Yeah, like it's the sort of people who can change disks out, or the machine's overheating, or things like that. They can often do this, and this is really effective because the PowerShell goes across the network and never touches the disk, which allows you to spread to another machine without ever triggering antivirus usually. So that's a really effective technique. Similarly with WinRM, that's Windows Remote Management A lot of more recent versions of Windows, you have the option of deploying it without a GUI and administering it from a central location using Windows RM. And the idea is it sort of makes it sort of like a machine. It doesn't have graphics hardware in it and that sort of thing. You can do pretty much the same as you can do with WMI with WinRM as well. So that's a really good technique as well. And lastly, well, there's a few others, but these are the main ones. You could actually, if you were on a machine here and you found a machine upstairs that hasn't been patched, right? You could just go and own it with some off-the-shelf vulnerability. I picked up Eternal Blue, which is that crazy vulnerability that was the NSA leaked. It's over a year ago, wasn't it? But which is really reliable way of compromising the Windows box over the network. The one from less than a week ago is RDP Bluekeep. So if you have a remote desktop, it's now, and if you've not patched it, you can compromise the machine using remote desktop without any username and password. It's really cool. So I gave them scores of things like, as an attacker, what you want to do. So remote desktop, yeah, only if you have to. Other vulnerabilities, they're really noisy on the network, the sort of thing that intrusion detection system picks up. I don't want to do those. PS exec, if you, yeah, sometimes it's all right if you've got your antivirus evasion, if your evasion techniques working well. But these two are really the two that we move around.
What's that? Windows RM?
WinRM? Yeah.
Yeah.
WinRM is used. So it's used for headless versions of Windows, right? Which and it allows you to administer them remotely without ever going on the desktop. Yeah. But it works on any version of Windows now. It doesn't have to be headless. And if you have an administration server, it allows you to do all the other things. And of course, it has a permissions model around it. The chances are we've got some credentials by this point that would allow us to use that.
Windows RM.
Yep.
Yeah, that's
Yep.
59864.
Okay, so we've got these things. Who would we like to compromise the most within an organisation, right? Well, we'd quite like to go after the domain administrators, right? Now, domain administrators are very, very powerful people within an organisation. So you've got domain administrator accounts. And what can these accounts do? Well, actually, they can do almost anything within the organisation. These are, they can log into any Windows machine, anyone, and they can, if you've got the right software, for instance, you could log into any user's laptop, start listening to them or looking through their webcam. Absolutely no problem at all, dead easy. They have access to every piece of information stored in every SharePoint and network drive share. They can read everybody's emails. They can delete everything. Oh yeah, they can do. There's no permissions on there. They're the ones that we want as an attacker. We can. Oh yeah, here we go. We dump everybody's users' password hashes, so we get everyone's passwords. So there should be as few as these as possible, right? These domain administrators. Quite often we break into an organisation and find several hundred of them, which is kind of bad. You probably also don't want to give them to your subcontractor either. Yeah, quite often we find that as well. What these accounts should be for, though, is they should be for administering the domain controllers themselves. In fact, that's the only thing that's safe to do them, right? Let's imagine for a minute that somebody came along and logged into this PC using a domain administrator account. That's a perfectly valid thing to do for them, right? Imagine we went up and ran MiniCat on that machine. What would happen? We could lift the password or the password hash out of memory. Maybe we have to crack it, and from there, from something, we can go and we can log into any other machine in the organisation just by becoming a local administrator on that machine. That's a catastrophic weakness, and you can imagine as an organisation, it's really tempting to issue domain administration accounts to people like desktop support people, because it allows them access to things. Yeah. Not only is it really tempting, it's really common, because somebody who's a domain administrator might also be administering lots of servers within the business. and those accounts just allow them to log in easily. And that's a really bad thing. So MiniCats is a sort of game changer for these. The other thing I like doing is I like trying to find out who has domain administrator privileges within an organisation. And it's a real hoot to go searching on LinkedIn, right, for name of the organisation you're interested in, domain administrator, to find out who they are. And, you know, if I was a real bad guy, I'd probably kidnap their children or something like that. Yeah, it's like... So I was talking to a woman who's a domain administrator for a large oil company in the Middle East, a very large oil company in the Middle East, and her company had bought her a new fortified house and gave her a full-time armed guard and her family full-time armed guards. That's how much they valued her services. I can't quite see some UK corporates doing that, but never mind. So what happens is we've got to this point where we have a number of techniques for spreading around, for gaining information, right? As an attacker, we'd quite like to bring these all together and put them all together into a coherent whole. And because we have all... In a large organisation, maybe it has several 100,000 employees, for example, and you're attacking it, you end up with the opposite problem from what you'd expect. It's supposed to be difficult to get this information. Actually, usually when you use these techniques, it's the opposite problem. You get so much information, there's so many users' accounts, you don't know which ones are the important one. It's a sort of, you have so, it's just, you're far too rich. It's just like, it's really unusual. So to do this, somebody, a group of people, and they're a really nice and clever bunch, have put together this particular software called Bloodhound. Right, so what Bloodhound does is it needs a single Active Directory account with the ability to query the domain controller, right? And what it does is it goes and gathers all the users, all the computers, all the group's members, the sessions, and a bunch of other stuff. And it takes it and it puts it into this thing called a Neo4j graph database. Now, I don't know how many people are familiar with graph databases here, but essentially what it does is it joins all these things together in a big database. And it allows you two different ways to query this. It gives you a fancy GUI to query it, and it also gives you a REST API to query it. Right? And so some of the sort of things it can do are things like this. Oh, I was hoping this was going to be a lovely high-resolution projector, but this is a real example from an organisation, right? So down the left-hand side here, we have user accounts which we know the passwords from these other techniques that we've done. At the right-hand side there, we have the domain administrator, right? What this does is it allows you to query, I have these, tell me how to get to these, right? And let's go through this, right? So, I have these accounts. That person is an administrator to that machine. That computer there has somebody else has logged into it. That other user, whose password we can get using MiniCat, of course, is a member of that group. That group is a member of that group. That group can log into that machine. That person there is logged into that machine as well. That person's a member of that group. That group can administrate that machine. That person's logged into that one, who's a member of that group who can log into that machine. That person's logged into there. You see how it's going, right to the left, to the right. You can just follow these three using techniques like MiniCats and WMI to log into these machines one after the other, and then you get a domain administrator. You have one when you've got to that point. That allows you to query it as an attacker in a few minutes, right? There's a problem with Bloodhound, right? It is unbelievably noisy to run. We've just talked to domain control and say, hey guys, give me everything you've got. Do you think anybody would notice it? Well, actually, in a lot, many large organisations, domain controller machines are completely under-resourced. They sit there maxed out at CPU and disk completely all the time anyway. I think a little bit more traffic to it, actually quite a lot more traffic to it, doesn't really bother them too much. They know the performance of them is rubbish. It's just the same as before. But essentially, this technique allows an attacker with very, very small privileges to become important privileges. Now, I picked on domain administrators at the right here, but actually I could pick on anybody in the organisation. So I'm Fred here, and I want to have the privileges John does, because John has got access to the payroll system. I want to see how much somebody earns. I can use that. I can use the exact same technique to do the same thing here. Okay, so that's Bloodhound. It's really powerful and really noisy. Right, putting it all together. So there's some tooling out there that allows attackers to do this. Everybody's favourite Metasploit actually can do this. It's really clunky to do it with Metasploit. And you've got to spend a lot of time doing antivirus evasion. It's really, really hard work. PowerShell Empire is a little bit better. It has a command line very much like Metasploit, and it's got the tools necessary to do all of the bits we've done. These two are open source. The third one's paid for proprietary software, Cobalt Strike. It's amazing. It's a lovely GUI, you can see it down there, and it allows you to do all these techniques. It also does, remember I was talking about the command and control later, where you have a central server as an attacker, you've got all these tentacles out in the organisation to machines that you've compromised. It does all of that. It also allows you to relay your command and control traffic between these machines using a variety of different protocols, and it allows you to make up network traffic profiles that are designed to hide in with the real traffic within the organisation. It's a very powerful piece of software. Real attackers have got that. We have seen in incidents real attackers are having even better software like this that they've written themselves. So very well resourced attackers indeed. Okay, so can you see that we've done quite a lot of damage to this organisation that we're just attacking here? So what are the consequences of that? Well, you can definitely read everybody in the organisation's email if you wanted to. And as an attacker, will routinely read and often delete and modify email within an organisation. And that's quite interesting from the security operations point of view. Imagine you were a security person within an organisation, you've got an attacker like this running around. You can't email your colleagues to tell them because you know the attacker is going to read it, right? So that's, maybe you need to do some preparation for this kind of stuff. The attacker probably has access to all information on network drives. So those are the people who were last month, when Rebecca was talking all this GDPR stuff. This is a GDPR nightmare if somebody pulled this off against you. You're certainly going to have to tell somebody like the Information Commissioner. Microsoft have got this bit, so you can put domain controllers in Azure, and they have them working with your own domain controllers, and you can connect them to Office 365, so you can do cloud type stuff. So if the attacker's done this to you, they can read all your stuff in Office 365 as well. You can Microsoft SQL Server, big database. They're all domain administrated as well. You can get those if you're in that point of view. You've noticed I haven't said anything about things like Linux systems and other Unix systems and Cisco. And actually most of those aren't actually authenticated with Active Directory. Increasingly they are. There's products like Vintela, which allow you to do Active Directory authentication on Linux machines. But it's no problem. All you have to do is find the system administrator for this machine, go and install some keylogging software as domain administrator on the machine, and then just watch them and wait until they type the password in, and then you just go and grab it and log into the Linux machine yourself. When you're a domain administrator, you literally can do absolutely anything. Right, okay, so somebody's done this to your organisation. How long is it going to take you to get them out of your network, right, if someone's done this to you, right? It's going to take you a long time, and you're never going to be quite certain that they're gone. If they're wanting to hide, you're in real trouble. Okay, so that was the attack bit, right? I guess I should talk a little bit about defence as well. So, how can you defend against this? It all seems too easy, right? So, Microsoft have seen these kind of attacks, and they're starting to put some protections into Windows to prevent against them. In particular, from Windows 10 and Server 2016 onwards, they've done something interesting to the LSAS process. So this was the thing that MiniCats could pull the credentials out of memory, right? So what they've done is they've split it in two. They've got the traditional one, which does the internal API to other programs, things like Outlook, and things that need access to the Windows credentials. And they've split it up. And what they've done is they've virtualized in memory another version of LSAS, which actually stores the passwords and the password hashes and things like that. So if as an attacker you come along as administrator, you're only in control of that operating system. That's a completely different virtual machine that's running, right? You don't realise on a Windows 10 machine that actually there's already multiple virtual machines running within the same box, but there always is. And what happens is it's actually really difficult to get from one to the other. Now, as an attacker, there are still some things you can do. So, for instance, you've got complete control of this process here. So you can hook them and get real time when people type passwords in and things like that. But what it does, it's only in the future. It doesn't give you historic ones, which is a real problem. So that's a powerful defense. It's patch your stuff, right? It's like install new versions of things. Actually, there's quite a few other protections. This is one we come across, Microsoft Advanced Threat Analytics, right? And it's sort of like, it uses a sort of heuristic techniques on domain controllers. It's a pain to implement. You've got to plug this thing in all sorts of strange places within your domain. But what it does is it looks at the kind of queries that users are doing on their domains, and sort of things like normal users don't ask for a list of all the users on the domain, and normal users don't ask all the people that are logged into another machine. And it puts together sort of heuristics, and it generates almost like antivirus for your domain. So that's a really interesting product. Of course, it generates alerts. You need somebody who understands those alerts at the other end and actually can do something with them. Yes, that's quite interesting. This is my favourite the defence. This one's really simple, right? So this is Jessica Payne at Microsoft. She's cool. She's a security researcher that works at Microsoft. And what she produced, which is really lovely, is a set of basically changes you can make to the policy on an Active Directory. And this one's really simple. Basically, what it says is ban domain admins from logging into anything other than the domain controller. Right? Now that might be a problem in some organisations where actually using these domain admins is part of the sort of embedded processes within the organisation. Organisations hate changing this kind of stuff, but this is the sort of thing that says ban them from doing this, and it's quite good because it stops people doing this by accident. It's really easy if you've got domain admin credits just accidentally log into the wrong machine. This would prevent it from happening. So this is a really simple thing that it does. Japanese computer emergency response lot in the Japanese government have done a lot of really interesting stuff around Windows domains, particularly to do with event logging. And they have PDFs on their GitHub site of all the different types of events that certain types of attacks generate. It's really interesting reading them. The other thing they've done is they've made this program called Login Tracer, and it uses the same techniques that Bloodhound does, but for event logging. So it makes a graph database. So it says, you've got this kind of events coming out of this machine over here, and these kind of events coming out here, and it joins them all together to show you how an attacker is moving around inside your Windows network. Now, you have to be really skilled to read this, but it's a very interesting thing to do. The other thing, of course, you can do is we use Bloodhound against a network. You can use it as a defensive tool as well. Run it. If you have an organisation you're responsible for the security of it, go and run Bloodhound against your own organisation. Absolutely anybody in the organisation can do so. There's nothing that's stopping you. And so you can find things like, find the accounts that are too powerful, that have got access to hundreds of machines. Watch out for domain administrators misusing accounts. As soon as they log in, they generate a session. You can see it as well. So security operations teams can be doing this themselves. And my final piece of sort of defensive thing is there's a user education piece here. And I say, don't be a muppet, all right? That's really important. Password policy is, it's just absolutely vital in Windows. From this all started off with stupid passwords that people have been using, or crazy stuff like, writing passwords on monitors. So there's a whole education piece around here that organisations can implement, and it's a real troublesome that one. because most people don't care. It's like they just want to, they just want to come in and go into their like call center job or whatever they do. Yeah, so this is a big problem for them. So, I'd like to wrap up. There's a lot about Windows security and domain security I haven't covered here. I've just been skimming across the surface. I really could talk about this all day. And then, yeah, there's a whole bunch of stuff that I'd love to talk about, but yeah, just really didn't have the time. But the key thing is, if you have a big Windows network, and Windows, I mean, I've basically talked about how to destroy it here. But Active Directories are really important for security as well. They do things like when an organization, when a person leaves the business, it allows you to kill them instantly off the system so they can't log into anything. It allows you to centrally manage the organization. These are important things to secure properly. But it can also be used for an attacker to wander around things very easily. It's particularly difficult actually to spot them doing it. It's really hard work. And I guess my last thing is watch out very carefully for physical security of network connections within an organisation. So things like these ports on the wall where people can wander around. I mean, there's techniques around, there's sort of these things, 8021X, which is like authentication to these ports. Quite often that's done on Active Directory as well, but yeah, it's okay there. MaxEC is a trendy new one for doing port authentication as well. So I think that's just about me. So thank you very much. Hopefully people have got some amazing questions for me. Okay, cool. Thank you very much.
Thank you. Thank you.